Okay, this lesson begins our next unit on interest. We're going to just do 3 lessons in it. There's really only 2 types of interest, simple interest and compound interest. So today we're going to start with simple interest. Our third lesson will be compound interest, and our second lesson in the middle will be kind of one bridging from simple to compound. So the reality is that simple interest is called that because it is relatively straightforward and easy to calculate, but it has very minimal real world applications. There are very few financial institutions that will use simple interest for anything. Compound interest is much more common, but again, it's a little bit more complicated, so we're going to work our way towards that. So to start this off, we're going to start with 3 equations, and even then, the third one is not really going to get used too much yet. We're going to take a closer look at that one in our next lesson. And the second equation is actually super straightforward and obvious to most people who understand what the variables mean. So let's go over the variables in these equations. The capital I stands for interest, and it's basically the amount of money that we're going to make for interest. Interest, by the way, is just basically extra money that you get if you lend money or extra money that you owe if you borrow money. So if someone said, "Can I borrow 20 bucks off you? I'll pay you back in 5 years," you might say, "Well, I don't really want you to take my 20 bucks for 5 years, but if you pay me back 30 or 40 or $50 in 5 years, maybe I'll do that." And that really extra money is interest. So our capital I is the amount of interest in dollars, and I don't want that to get confused with our R, which is an interest rate, which is a percentage of the money per year that we have to pay. P is the principal, which is really a fancy way of saying the starting amount that we're either going to borrow or lend. And T, time in years. Always, always, always in years. And likewise with our interest rate, R, it's always going to be a percentage of our overall amount in years. Those 2 values have to be in years. If they're not, they don't work quite right. What we're going to see is 2 different variables in the third lesson that are similar to those, but deal with things when we're not in years. And then finally, A, the accumulated amount, which is basically just the amount that we'll have at the end. So if we're investing, it's how much we'll have invested after the investment is over. And if we're borrowing, it's how much we owe back at the end of the loan. So the first thing we're going to do is just make sure that we can convert everything, any type of time we get, into years. And this is fairly straightforward. We know how to do unit conversions. These ones are single step unit conversions. I think they're simple enough that we don't need to go through our formal process of making a unit chain and doing all the fraction stuff. Really what we can do on the first one is just say, okay, 6 months. There are 12 months in a year, so 6 over 12 equals 0.5 years. Similarly, 13 weeks. There are 52 weeks in a year, so 13 out of 52 equals 0.25 years. And 37 days, well, that's roughly 1/10 of a year. There's 365 days in a year. But we're going to pull out a calculator for that one and do 37 divided by 365, which is 0.10136 years. And while I'm not going to worry too much about exactly how many decimal places or significant digits I keep, I do want to point out that in this unit, it is always a good idea to keep a couple of extra on top of what you would normally do, especially for some of the variables later in the lessons, later in the unit. You'll see that there can be quite a major impact if we don't keep a few extra digits. Rounding off can mean a significant difference in the amount of money that we owe or borrowed. So for question 2, this is the first of our kind of standard solution type equations where we're going to figure something out. And I want you to use this method that I'm doing here. It's actually pretty straightforward. You may have seen it in science. There are different names for it. I've seen it called grass. I've seen it called a few other things. But it's basically just we start off by reading through the question and then writing down things we know and things we're looking for. It just makes everything a lot easier. So in this case, I'm just going to kind of go through. I usually read it once and then go back and kind of check for things one at a time. So that's what we'll do here. $400 is borrowed at 15% a year for 5 years. How much is the total interest charged? So $400 is borrowed. That's how much the loan in this case is going to start with, or the investment's going to start with, which is the principal. So I'll just write down P equals 400. At 15% a year, well, there's only one thing that has percentage in it so far, and that's going to be our R, our interest rate. So our interest rate is 15%. And if you like at this point, you can convert your percentage to a decimal. We're going to have to anyway. Might as well do it now. We're investing for 5 years, so that's going to be our time. And remember, these always have to be in years, but we're already in years, so that's okay. And then how much is the total interest charged? So how much is the interest really just means that interest is the unknown. That's the thing we're looking for. Okay, so let's look back up at our equations. And now that I should go back and point out for the equations. The first one is kind of our main equation, I equals PRT, which tells us that the amount of interest that we build is going to be equal to the principal, the starting amount, times the interest rate in percent a year, times the number of years. The second equation, A equals P plus I, this one's the common sense one. This just says the amount that we have at the end is the amount that we have at the beginning plus the interest. It's pretty straightforward. And the third one, we're going to kind of leave out for now. And we're going to come back to that in our next lesson. So looking at the variables in question 2, we have P, R, T, and I. Well, that looks like all of the variables from the first equation. So that's the one we're going to start with. I equals PRT. And now we just plug in what we know and solve for what we don't. So I, we don't know. P is 400. R is 0.15. And T is 5. So if I punch all that into my calculator, 400 times 0.15 times 5, that equals 300. So what that means is that we just built $300 of interest. Pretty straightforward. Let's try the same thing with question 3. How much money must be invested? I should read the question first. How much money must be invested at 18% a year to earn $500 in interest within 180 weeks? So the first part, how much money must be invested, that's asking us how much we're starting with, and that would be the principal. So the principal is our unknown. 18% a year is our interest rate. So 18% or 0.18. To earn $500 in interest, so that's going to be our capital I. And within 180 weeks, which is our time. Now I got to be careful here because 180 weeks is unfortunately not in years. So in order to convert that to years, I'm going to do 180 divided by 52, which is the number of weeks in a year. 180 divided by 52 is almost 3.5, 3.4615. And again, I'm going to try not to round off that one too much. So now I look at my list of variables, P, R, I, and T. And even though they're in a different order, that is our I equals PRT equation. So I equals PRT. Now in this case, we have a different unknown than we had in question 2, but that's okay. We just fill in the things we know and leave the things we don't know as variables. So I'll plug in 500 for I, P stays P, 0.18 times 3.4615. Now my next step, what I'm going to do is just multiply the 0.18 times 3.4615. And I'll point out that I have the exact value for t staying in my calculator. So if you wrote it down, cleared your calculator, and punched it back in, your answer might be slightly different than mine, just because of a slight rounding error at the end. But for now, we're not going to worry too much about that. And this is 0.623077, roughly. And then the final thing we do to get p by itself is divide 500 by 0.623077. Oh, just 2 seconds. And when I do that, I get 802.47. So I could write down 802.47 equals P, or I can write down P equals 802.47. Once we know that those two things are equal, it doesn't matter which one's on which side of the bracket or on the which side of the equation, so we can switch them. And it's a little bit prettier to put down the P equals. It's always nicer to express your final answer as variable equals. So if we want to make $500 interest in 180 weeks at 18% a year, we'd have to invest $802.47. Now one more. Question 4. If we want to make $200 in interest in 900 days, at what rate must I invest? Okay, so the first part here, I want to make $200 in interest, so that's I equals 200. In 900 days, that's a time, except that it's a time in days and not years. So I'm going to convert it to years by saying 900 over 365. And that is 2.468. Again, rounding off a little bit there. I think it's 5753 something. But anyway, it's close enough. As long as we keep a significant number of digits, we should be accurate. So really, this is years, right? So by the time we get down to 3 decimal places, we're talking about the correct amount of interest within a couple of days. And by the time we get to our 8 there, our 4th decimal place, we're talking about correct interest within a couple of hours. So I think we're safe at this point. Okay, at what rate? So it's asking us to find the rate. So I'm going to put rate equals question mark. And must I invest $700? So if I'm investing $700 at the beginning, that sounds like principal to me. Oops, sorry, that's not unknown. That's $700. Okay, so I put my equation, I equals PRT, and I know that I is 200, P is 700, R is unknown, so we leave it as R, and T is 2.4658. Now this often confuses students because they're not sure how to deal with the right-hand side, but remember, order of multiplication does not matter. And what that really means is that as long as we multiply those numbers together, we can multiply them in any order. So I'm just going to do the 700 times the 2.4658. And that gives me 1726.03 times R. And now in my final step, I'm going to divide both sides by R. So 200 divided by 1726.03 equals 0.11587. Now I could write 0.11587 equals R, or I can write R equals 0.11587. And I'm going to remind you that since this is an interest rate, we'd like to express it as a percent. So in order to convert that to a percent, just multiply it by 100%, and that gives us R equals 11.587%. And if you rounded a little bit on one of the steps or didn't keep the numbers in your calculator like I did, you may have gotten a slightly different rounding. As long as you're getting a number between 11 and 12, I think you're okay. But you're probably got a number around 11.5 or 11.6, and that's more than accurate enough. Okay, so there are a few practice problems I would like you to try now. Most of them are just like the ones above, but I want you to make sure that you're paying attention to things like keeping everything in years if it isn't in years. And rather than give you the exact values at the bottom, I've given you some approximate values. So I put down things like just under $1,400. So if you got a number like $1,380 or $1,372, then you're pretty sure that you're right. In most of these equations, if you get the answer wrong, it's because you multiplied when you were supposed to divide, which creates a huge difference between the correct answer and what you got. So if you got like $7 for part 1A, then yeah, you know you've gotten something wrong. But if you're anywhere in the just under $1,400 ballpark, you should be fine. The other reason I did this is because you can get some rounding error because of significant digits and stuff, and I don't want you to think that the exact answer is really exact. It just works out that way depending on how many significant digits you keep. So give it a shot. If you're having difficulty with any of these, let me know. I'd be happy to help out with whatever you're having trouble with. And otherwise, I will see you in the next lesson.